people already. So if I'm wrong, tell me. Has anyone heard of? Oh, I guess I got to get a microphone.
We're going super ghetto.
All right.
When you're over there, you're on screen. Over here, not.
Yeah, I'm a walker, so
you're good.
Sorry, everybody. Oh, this is the camera.
Yeah.
Sorry,
well,
everybody. I'm a walker.
We can't get your screen, so I'm just gonna do it really ghetto. Just
Say
point
hi,
the camera.
say hi to the live stream that nobody's watching.
Yeah. Okay, cool.
So anyone heard of Ward Cunningham before? Please tell me who heard of Ward Cunningham. One of the signers of the Agile Manifesto, I believe. Oh, yeah. Okay. Anyway, something called Cunningham's Law. You heard of this before? Cunningham's Law says the best way to get the right answer on the internet is not to ask a question. It is to post the wrong answer. That's what I'm doing. I'm posting the wrong answer, hoping that someone's going to correct me and say, well, actually, you're wrong about it. This is more correct. So please do that. I'm not an expert in any of these databases. I do spend a lot of time on Couchbase, obviously, so I know a lot about that. The other ones, I'm trying to be as fair as possible. All right? Okay. Take a breath here. Any questions so far? Almost stunned you into silence. Okay. So these are my evaluation criteria. I've come up with these. Think of these as like the columns in the matrix where I'm about to fill out. You're going to see some amazing drawings here. So the first is querying. I mentioned early on some of those core operations for document databases. Key-based operations and maybe a map reduce or something along those lines. That's sort of the baseline. Everybody has those. What else do they have besides that in terms of querying? Scaling. So all these databases are mainly designed to be horizontally scaled, right? Horizontal scaling means we add more machines to a cluster, as opposed to vertical scaling, which is we take our one node, our one machine, and move it to a bigger box, faster processor, more RAM, more disk space, etc. Vertical scaling is super easy to do, but there comes a ceiling, in cost or in other factors in terms of like availability that you can't do with just vertical scaling. So I'm going to talk about how easy is it to horizontally scale, what are the decisions I have to make, and the different types of scaling. Usability. So for us as developers, we're used to having to fiddle with command lines and obscure settings in INI files and that kind of stuff. But in my point of view, I think software for developers should still have a focus on usability. And the easier it is to use, I think the better it is for us. So the common usability sort of mantra is make the common things easy to do and make the rare things popular. So I'm going to try to evaluate these databases based on how they deal with that. But there's a trade-off here as well. Sometimes making something easier to use also makes it easier to do something bad with security. So keep that in mind as well. Speed. A lot of NoSQL databases love to make claims about speed and publish benchmarks. This is kind of where I wish I wasn't on camera right now to talk about benchmarks. But let's just say certain companies, all the companies, like to publish benchmarks saying how great they are. But they're not going to publish benchmarks. Oh, I don't know. Thank you. They're not going to publish benchmarks to make themselves look bad, right? So they're going to cherry pick benchmarks, or they're going to test against certain older versions of their competition, things like that. So I'm always skeptical of benchmarks. Now, benchmarks are important to test your latest build against your old build internally, right? Those are vital. We made a change to our database and it drops performance by 20%. We need to be aware of that. So that's a great use of benchmarks. If you are evaluating databases, it's important for you to run benchmarks to see, well, I'm going to run this type of load on my database based on my use case. How do the databases respond? So I'm always wary of benchmarks, but I'm more focused on architecture. How does the architecture affect the speed of the database, generally speaking? Deployment, we're going to focus on Microsoft, so everybody's going to be pretty much on Azure and Windows, but it's nice to know what else I can deploy if I need to. I need to run on Mac, if I need to deploy to Docker, Linux, etc. And supports. So pure tech is not the only thing that matters. Here's a quote from actually one of the RavenDB guys. He says, the biggest challenges in adopting NoSQL are usually human rather than technical. So I want to focus on who is doing the support, What are the licenses like? Is it open source? Is there a big community? Are they going to be around a year from now? Are they innovating and adding new features, or are they just kind of coasting? That sort of thing I want to talk about with these databases. So those are the criteria I'm going to use. I mentioned assets as I went along, but which of these are most interesting to you? Which are least interesting to you? I assume it's mostly developers in here, right? Maybe some DBAs based on the questions right there. Is there anything that's a glaring omission from these criteria? Cost. Say that again? Not required DBAs? I would say it's a fallacy. Yeah, I think a DBA can be very effective, very useful with NoSQL. If you think you're going to adopt NoSQL with the mind in mind of cutting DBAs out or getting rid of DBAs, you don't need DBAs. I don't think that's necessarily true. If you need a DBA for SQL Server, you probably need one for NoSQL. Your question was about cost. I will definitely talk about that when it comes to license. Yes, that's definitely part of how big is the community, how responsive is the community. The question was for the live stream, how easy is it for a company to find people that know these tools? We try to repeat questions now since we're live streaming. Okay, I'm going to start with the big guy, MongoDB. Anybody using MongoDB in here right now? Two, three-ish. One guy's kind of like, he's not sure if he's using MongoDB.
I don't use it, but our software supports it, so
Okay.
it's racking.
Okay. Very good. Same with you. Work for the same
More or
company.
less, no, not at all. My final project is actually integrating with Skillsoft and with integrating with MongoDB. So
Okay.
we're making API calls.
I see. So it's just integration support for you. It's not like you're using it as the back end of whatever project. Okay. Great. So a few of you are using this. So if I'm wrong, you guys please correct me. All right. So let's start with querying. You're going to query Mongo. They have a query language. It's a proprietary on there. Maybe not true-ish, but it's a JSON-based query language. So you write a query using like a Mongo JavaScript type of syntax. So you say like db.collection.find. And you put in a JSON expression that helps you find, this field is greater than this field is less than this, that sort of thing. That's the query language you write with Mongo. It is somewhat limited in the fact that there's not really a thing like a join. There kind of is a thing called a lookup. There's not a join. And it just looks, it's something you have to learn if you've not used Mongo before. There's a text search in Mongo as well, so if you're doing like a search engine type of functionality, Mongo does have that available. They have an official .NET and .NET Core SDK that they support, and they come with a link provider, .NET. But the link provider just generates this query behind the scenes. So the link has a join, but it's not going to work. So it's not going to work how you think it works if you're trying to use links with Mongo. Now, before we talk too much about joins, I think there's a lot been made about I can't use a join in NoSQL. Sometimes you don't necessarily need a join as much. So the modeling is different. But it is nice to have, right? Just in case you do end up using it. So that's the Mongo story. Now I say it's proprietary, but as we'll see here going forward, some people have been sort of trying to adapt that Mongo API and use that and treat it as kind of a standard in their NoSQL database. We'll see some more of them. For scaling with Mongo, it is a little bit complex. There's multiple node types. So hopefully you guys can back me up on this with the Mongo. But you can create a master node and slave nodes. You can create another node to actually do the administration of those other nodes. So like you need at least 4 different types of nodes to get started with the scaling production ready Mongo. Now you can still just do a single node on your development machine and get started with that. If you're doing a small project, fire a single Mongo node, you're going to be fine. But when it comes to scaling, it is a little bit of work. And if you're an ops guy or a DBA or used to this kind of thing, you're probably totally comfortable. If you're ops ignorant like myself, you're going to have a tough time getting this to work. So generally, I kind of don't like the master-slave primary-secondary approach. I'm more in line with the peer-to-peer masterless approach, which we'll see in other databases that I cover. Usability. So when you install Mongo, you get command line and you get a REPL kind of thing out of the box. You don't get any sort of UI. There are several UI options out there, like MongoDB Compass is their official one, I believe. There's some other tools out there like that. You can install and run that as a desktop program. And then back to the scaling question. This is kind of introducing something I like to call decision fatigue, or I've been heard called decision fatigue, is that you want to start scaling, you have to make decisions, a lot of decisions along the way, including how do I set up replication? How do I set up sharding? I have to configure, okay, how am I going to shard this data among all my different nodes? Everybody knows what sharding is, familiar with that concept, to split data into distinct pieces. That's kind of the key to horizontal scaling, is somehow you shard it between all the different nodes. Yes, you split up the data, like, so the question, how is it split up? That's what you have to decide with Mongo. You say, okay, I'm going to shard it by a certain field or a certain ID that I'm creating to shard it, that sort of thing. You have to make that decision. So that's a usability concern, I think, because it requires you to make a lot of decisions to get up and running with that. And so either people just don't make the decisions and skip it, and they end up with something that doesn't scale like they think it will, or they have to spend a lot of time going through all those decisions. And it's kind of taxing. The more decisions you make, the more you look back and say, what if I had made a different decision? How would that affect my choices today? So you get this huge tree of decisions you have to make as you go forward. With speed, this is going to be a theme you see for a lot of these databases, is indexing is extremely important. So I know you're probably familiar with indexing from the relational world. You create indexes on tables before. Or maybe you create a table and it's only a few hundred rows. It's not that big a deal if we do a table scan. So I'm not going to bother with index right now. Just leave it the way it is. With a NoSQL database, that is not the way to go. Because you don't have a thing like a table in NoSQL databases. All the documents are together in like one big bucket. So you might have the invoice document in the same bucket as the user document. So if you want to scan the whole bucket based on a query, that's going to be very slow, and it's just not going to be a good idea. So indexing is vital. Mongo does have some in-memory options. So by default, Mongo is disk-based, right? You're going to, when you get documents, you're going to be going to disk and getting to disk and writing to disk. But there's some in-memory options. You can say, okay, I want an in-memory Mongo collection or bucket or whatever they call it. And so that data is just in memory, so it can be used as like a cache. It can be much, much faster. But you don't have any sort of hybrid. It's either in memory or it's disk. You can't do sort of both of those together. This is why you'll see Mongo often paired with Redis for caching. So you need Redis next to Mongo, have those both together. All right. Deployment, Mongo can go everywhere. Windows, Mac, AWS, Google Cloud Platform, all those sorts of things. You can, of course, run Mongo in a VM and all of those. And like the Azure Marketplace, you can spin up a Mongo cluster, that sort of thing. They also have what's called a DBaaS, Database as a Service, called MongoDB Atlas. So if you don't like the DevOps stuff, like me, I don't like that kind of ops work, you can just use Atlas, sign up, and they'll handle all the scaling and stuff for you. But it's totally cloud-based, it's not an on-premise. Is it premise or premises? Premise? It's not an on-premise solution, it's cloud-based. And there's some competitors for that as well. There's Mongo Lab and Mongo Soup. They also offer the same sort of thing. So lots of options there for DBaaS. So that's definitely a plus for Mongo. Easy to get started. I think we even have a free tier. You can start using Mongo right in the cloud immediately. That's definitely a plus for them. Support. If you want to buy support, you're going to get it from MongoDB Incorporated, who just went IPO just over 6 months ago. And in that IPO, they have to list in your IPO a document that shows like different risks to your offering, your IPO. One of them they list is that Mongo is licensed under AGPL. Some enterprises are not comfortable with AGPL as a license. Apache's up there because the .NET library is Apache license, but the Mongo server itself is AGPL. Yeah, go ahead. AGPL, it's the I think what the A stands for, but then GNU private. What's the public license? Oh, that's public license. Sorry. What's the difference between AGPL and GPL? AGPL I think is slightly more lenient than GPL. I'm not. You're asking the wrong guy. What's the question? But I just know that AGPL sometimes an enterprise is not comfortable with that license.
GPL makes you release your source code and you use for that.
Right. Right. So GPL you have to release your source code. AGPL I think there are some fewer restrictions on that. But like Apache and MIT, for instance, are much more enterprise-friendly licenses. Assuming your enterprise is in open source in the first place, right? Now, one thing Mongo's got going for it is definitely they're the most popular. They have a huge community, huge popularity. So if you have problems, if you're looking to hire someone in Mongo, it's not going to be a problem. There's lots of engines out there, lots of people using it. That's definitely a plus in their column. All right, so that's Mongo. Any questions on that?
Mentioned that MongoDB is integrated
MongoDB is integrated with DB2 in version 11.2 with DB2.
Yeah.
What do you mean by integrated with?
Yeah, for API Mongo.
You can use the Mongo API with DB2?
Yeah. Oh. You can create actual JSON database and use that.
I know that. That's very good information. We'll get to Couchbase. Don't worry, I'll definitely talk about Couchbase. Any more Mongo questions? All right. Next one is CouchDB. First off, if you take nothing else away from the session today, take this one thing away. CouchDB is not Couchbase. They are not the same thing. I will explain more about that later, but they're different pieces of software. They're not the same. That's probably the number one question I get asked at the booth when I'm running it. Oh, aren't you the guys that, aren't you the paid version of CouchDB? No. All right, so CouchDB is another document database. In terms of querying, it is very REST-focused. It's a REST-oriented database. So when you interact with CouchDB, it's going to be over a REST interface with the HTTP call over HTTP API. CouchDB has that MapReduce thing I mentioned before. That's very, very, one of the things they're very, very good at. CouchDB has that really good MapReduce functionality. In fact, I think, as of today, Couchbase still uses that part of CouchDB for the MapReduce engine in Couchbase, I think. In CouchDB version 2, they introduced something called the Mango query language. You can see it's kind of a play on words here. It's a, what do they call it? They say it's a Mongo-inspired query language for CouchDB, which means it's kind of like that JavaScript-based JSON interface of query. I don't know if it is strictly compatible with Mongo, but it is very similar to it. That's in CouchDB version 2, which I think is at least about a year ago. In terms of, we'll get to that later. Okay. Scaling. So CouchDB is, I think, a little bit better. We're going towards better here in the scaling. So CouchDB goes single node type, single piece of software that runs on every single node. It's a multi-master. So it's not a master slave. Every single node can do both reads and writes. Right? It's not like a read-only copy. They can read and write. There is some additional work you have to do. So if you want to do a multi-master, you have to set up something like a proxy in front of all these. They recommend HA proxy. go to the website. That's what they recommend. Use whatever proxy you want. And you have to do a sharding configuration. So like Mongo, you have to define how are you going to shard your data. And you also have to configure replication. So you have to say, okay, I want this one to replicate to this one to replicate to this one, or whatever. Set that all up. And there's a caveat with replication as well. When removing a node from a cluster, you have to make sure you move those shards away. So if you want to take this node out, you have to move those shards over yourself first, then take the node out. All right. So there's some manual work involved here, some more ops stuff you have to do. But I think the scaling is a little better because of the full-time master system. With usability, when you install CouchDB, you get a web-based UI right out of the box. In CouchDB 1, it's called Pluton. CouchDB 2, it's called Photon. I don't know why they changed the name, but they're nice web-based UIs you can use to manage your cluster. The same sort of decision fatigue is there with scaling replication work, but with CouchDB 2, they've got this thing called a cluster setup wizard, which helps take some of that ops work, those decisions away from you, which is nice. There is not an official .NET SDK. There's several open source community .NET SDKs out there. I think the most popular one was doing my research. But really behind the scenes, it's just a REST wrapper. So you don't have to use a .NET SDK. You can use your own, just drop down the REST or write your own REST wrapper, interact with CouchDB. But I don't think any of these SDKs out there are supported by the Apache project itself. I think they've made a change recently. I hope they have. This used to be insecure by default. You install CouchDB, you get anonymous admin access to all the data by default, which is really nice when you're getting started because you can just go right and start working. But if you deploy it to production, bad times because now you can get a ransomware on the internet. Yeah, question.
That's also called behavior for Mongo.
Yeah, I didn't mention that. It was the default behavior for Mongo as well. You get anonymous admin access out of the box. They have changed it. And I think CouchDB has also changed that in the later version.
That's what you would say Armageddon for Mongo. But that was on the part of the developers.
Well, this is kind of what I'm getting at, is that this makes our developers' life easier, right? But you have to remember to secure it before you go into production. Which obviously developers, it even says in documentation, don't deploy this to production, but we don't read documentation, do it. Speed. So Mango, since you're doing queries, you have to have some indexing, so same thing goes for Mango there. MapReduce, as I mentioned, is a great feature of CouchDB. They're one of the pioneers in that area. It's very, very fast. CouchDB does not have any caching. So it's purely like disk-based. And they've said on their website, if you want caching, you are on your own. So bring something like Redis or Memcache or something else to do the caching for you.
I hear there's a whole company based on combining CouchDB and Memcache.
Stealing my segue. Yeah, right. Yes, absolutely right. Spoiler alert. But with CouchDB, you don't have any caching. It's completely on your own for the caching. Deployments everywhere. Now, the one caveat to this, and I meant to look this up yesterday, but I forgot to, is when I originally did these slides, there was not a CouchDB 2 image on Docker Hub yet. So if someone wants to Google that to see if that's still the case, I would appreciate that. But there's a CouchDB 1 image on Docker. I assume there would eventually be one on the CouchDB 2. As far as DBAS, database as a service, this is an Apache project. On the Apache project website. It's not like a DBAS offering that Apache makes for you, but IBM created their own fork of CouchDB, and they call it Cloudit. This is the cloud-based IBM-backed DBAS called Cloudit. So if you want to move from using just straight open source community support to having a company running support, IBM is probably the path to go to using CouchDB. The which kind of is this slide here with the licensing. Yeah, so source and packaging project. It's there's lots of people out there using CouchDB, even though it's kind of low on the popularity list, as I showed earlier. We've got a pretty big community. It's been around for a long time, 2005-ish. Before you go to cloud, I've got Couchbase crossed out here. It used to be the case that Couchbase Sync Gateway, which is part of our mobile solution, was API compatible with CouchDB. With our latest release, that's no longer the case. So CouchDB and Couchbase, the latest version, they would talk to each other directly. Okay. So that's CouchDB. Any questions on that? Yeah.
Those are redundant.
You can set up replication if you want to, but I don't think they're redundant by default.
Okay, so one of those servers goes down, and you don't move your shard.
Then you lose that data. Which is why you should set up replication and monitor it. Yeah. So it's a little extra work. That's really true of any database. It's just a matter of how much work is it to set up replication and how do you handle that data? Sorry, I didn't repeat his question, but he asked about what happens if you don't have replication set up and the node goes down. You lose that data until you can restore a backup or set up replication. All right, Couchbase. All right, so 2009. There was a company that provided support, integration, feature development for CouchDB called, what was it called? Couch1. A company called Couch1. Around the same time, there was an open source project, it's still around, called Memcache, however you say it. And there's a company based around that providing support, feature development integration called Membase. So you have one company that's this based, and one company that's really memory based. Looked at each other and said, hey, what if we get our chocolate and peanut butter together, create a database that's memory first, but backed by disk, and let's do a merger. So they took the couch from Couch1 and the base from Membase, created Couchbase. And a new piece of software called Couchbase Server. Now in the early days, Couchbase Server was still Memcached compatible. It still is to this day Memcached compatible. It used some bits of CouchDB under the hood, but it is not a compatible version of CouchDB. It is still Membase, Memcached compatible for backwards compatibility reasons. But it's a whole new piece of software. Just for example, CouchDB is now version 2, very recently. Couchbase is just about ready to release version 5.5. So we made a lot of major breaking changes along the way. They both have Couch in the name though, hence the confusion, right? But no one gets SQL Server and MySQL confused. They both have SQL in the name. I'm not bitter. Yeah, Java and JavaScript, same thing, right? Have you guys been seeing that whole Laurel and Yanni thing on Twitter? Sometimes I feel like that. Like, people are saying Laurel and Yanni, and they're saying Couchbase and CouchDB as if they're the same thing. No. All right, so with Couchbase, this is the one I know most about, most biased at, so please take your salt and throw it over your shoulder right now. With the querying, one of the things I love about Couchbase, the reason I work for Couchbase now, is that you have Couchbase. You can write SQL queries, full ANSI compliant SQL, join, insert, update, delete, merge, aggregates, whatever else. All the SQL you can stand. MapReduce, also in Couchbase, we're kind of telling people to stop using MapReduce unless you absolutely need to. Using it one day. Full text search, building the Couchbase, we have our own text engine. So it's not Lucene or Full or anything like that. It's our own text search engine, that's called Lead, building the Couchbase. We have a fully supported .NET, the .NET Core SDK. I think they follow the idioms of .NET pretty well. Mongo is a little bit wonky, but not that bad. I think they follow the idioms of .NET very, very well. So if you're used to dealing with like ADO.NET, the standard .NET way to query data, you're going to be very comfortable. There's also an open source project, community-backed project called Link to Couchbase. This is not supported officially by Couchbase yet, hopefully soon, but you can write link, it's generated SQL behind the scenes, just like the framework. So if you like link, you can use it with Couchbase. Brief explanation of MapReduce. Yes. All right. So you have documents in the database, right? 1,000 documents, let's say, and you want to query those documents in some way, right? You want to do aggregation or just return certain fields or return certain documents. Kind of like a query. What you do is you create a function, usually JavaScript, and this is a pure function, so it can run in parallel. And you feed every document through that function, that map function. You go through some logic and say, okay, if this, then submit the document, otherwise don't submit the document. And you can also reduce them through some aggregation, so counting, things like that. And then, so it runs all documents through that MapReduce set of functions, writes the result to this. And any new mutations that come in also go through that MapReduce function and write those changes to this. And then you query MapReduce on this directly. Kind of like a materialized view. You guys have used that before. If you write it in JavaScript, you can't do things like join and some limitations on it. But it is very, very performance because it's parallelized and it writes the result ahead of time. Not great for ad hoc stuff, but really great for certain aggregation use cases or like read-heavy use cases. Now addresses your question, I think, was about reads. That might be one path you want to do if you have a high read system. MapReduce might be the way to go for that. Okay, that's querying with Couchbase. Scaling. So Couchbase is also a single node type. Every node is the same piece of software. With a multi-master or a masterless system, every node does read and write. Sharding is automatic. You don't have to configure sharding at all. It'll determine which node to put the document on. It's a deterministic way. Don't think about it. Replication is not quite automatic. You have to actually click a checkbox and then click a drop down to select how many replicas you want. So here's that. XDCR, cross data center replication, is a very cool feature of Couchbase. If you have a cluster in like the east data center and a cluster in the west data center, and you want to sync the data between them, 2 clicks, XDCR, data will start replicating between those 2 clusters. This is one of the killer things about Couchbase. A lot of customers choose us just because of that functionality. So scaling is so easy, even an ops dunce like me can do it. And to make it even easier, we've got a Kubernetes operator that we created. We've got a DBaaS offering we're rolling out, all that kind of stuff. So this is really, really great for scaling. Usability. Like CouchDB, we have a built-in web console. So you install Couchbase, you get a web console out of the box. I mentioned Gideon already. Nicholas does SQL, so who here knows how to write SQL? You guys can all write queries in Couchbase. It's not exactly the same as Transact SQL, but scaling is super easy. Anybody here use Node? One guy? Okay, I'm going to skip this slide. Sorry, we can talk later. With security, now, Couchbase 4 was kind of secure by default. You could create a bucket in Couchbase with no password on it if you wanted to. And then if you expose that to the internet, anyone can get in that bucket and change the data. Couchbase 5, we've said no. You need to create a user with permissions and roles in order to get any access to a bucket. So version 5 is secure by default. But the usability trade-off, though, you have to take another couple steps before you can start interacting with your data. So we kind of push back on the security a little bit, which I think is a pretty reasonable trade-off. We don't want to be in the headline over the next year or so. All right. Speed. Couchbase is that combination of memory-first architecture with written disk. So it comes in memory first, gets written to disk asynchronously. Indexing is important, so we're talking SQL again. Gotta have some indexing, otherwise your queries are going to be Either they're not going to run at all, or they're going to be very, very, very slow. So indexing is important. We publish some YCSB benchmarks that show how great we are. So check those out if you're interested. We also have something called memory optimized index. So we create indexes that exist just in memory. And that makes them faster, but of course you need to feed more memory in order to accomplish it. All right, I already explained Memcached and Couchbase. Deployment, Couchbase can go everywhere. Here, we are in the marketplace for Azure, Amazon, even Google Cloud. So you can go to the marketplace and it'll create a cluster for you. It's using VMs though, so you still have to manage those VMs. That's where your DBA or your sysadmin is going to help you out there. We also have official Docker support, and we also have a Kubernetes operator. I think we're kind of a pioneer in that case. Not many database vendors have official Kubernetes operator, at least yet. So if you guys are into Kubernetes, we are betting heavily on Kubernetes. And we have a database as a service. It's not quite the same as MongoDB. It's more of a white glove service. So it's not something you can go to a website, sign up for, and get a free tier, start playing with it right away. Okay? It's more like you click on a button, contact us, and we'll help you. We partner with Rackspace to actually manage your cluster for you. So it will do the hard work of the managing of that cluster. So that's something we offer. The traditional DBaaS is not something that we have yet. It's something we hope to get to eventually. Support is provided by Couchbase Incorporated. You can get support deals with us. Couchbase Community, completely open source, Apache 2 license. You can go to production with the Community Edition if you want to. But there are some differences between it and the Enterprise Edition in terms of features. And obviously, you only get community support with the free version. Something to think about there. That's Couchbase. I know lots of stuff about Couchbase, so what kind of questions do you have? Say that again? Is it a REST wrapper? Well, some parts of it use REST, some parts of it use, I think, just TCP/IP. So it's kind of a hybrid. And of course, Couchbase has a full REST API. The REST API is mainly for like cluster management, admin, automation, things like that. It's not meant to be used for CRUD operations. Unlike CouchDB, which we're using REST for everything, Couchbase, we have a REST API, but it's only for adding a new node or creating a new bucket, admin sort of setup tasks. What else?
That's probably not appropriate for this different session. What kind of glue are you using to make a NoSQL database?
Well, actually, I don't know if I can answer that completely, but I do have a raffle prize here that we'll give away. It's a book, Nickel, A Practical Guide. So we'll be giving that one away. There's also a free PDF version of this, by the way, that I can give you a link to. That's more about how to use it. But we made a commitment to SQL for JSON back in version 4. We thought that it was what the market needed. People know SQL, they like SQL, and they want to keep using it. And I don't think anyone else, with the exception of Cosmos, which we'll talk about in a second, is doing anything like that. So it's one of our most unique offerings. It's why I really wanted to do the Couchbase. Yeah.
To go along with that, my company one was looking at using MongoDB as a production database. Project we were working on had a reporting component. Of course, we use information for that. Is this like the best approach for all? I mean, could you do heavy reporting on Couchbase?
So the question is, can I use Couchbase for my reporting? I don't need to bring any relational to the equation at all. The answer is maybe. So with just Nickel, when I'm talking about Nickel queries, it may not be the best idea if your reports are very complex, need a lot of heavy indexing. But we have what's called Couchbase Analytics, currently in developer preview right now, which is just another service you can click a checkbox to, and it provides what they're calling a no ETL solution to analytics. So you say, okay, analytics, I have an analytics node, I want to shadow this bucket. So it's going to make a heavily indexed copy of your data that gets updated in real time, and you query that for your reports. So it does not affect your normal operation. Your customers are not going to feel the effects of that heavy report query. Right? So we have something for that coming. Someone else has questions?
What's the worst use case?
What's the worst use case in Calculus?
Wow, that's a good question. Blockchain.
Yeah. You say blockchain, but I think we had a blog post recently showing like a hypothetical cryptocurrency stories in Couchbase. So, what's the worst use case in Couchbase? I think if you don't have the need for a big scale of data, I don't know if you need all of that Couchbase. You can just use, a smaller relational database like Postgres or Access.
I'm sorry, I
Yeah.
had to.
Yeah, because I don't want to tell you not to use Couchbase, but if your data is not going to be in the, approaching the gigabytes and the high gigabytes and terabytes, I don't know if you're going to get a lot of value out of it alone. That being said, there might be reasons to use Couchbase for a smaller data set. SQL, for instance, is great. You get the flexibility of the schema and you get SQL with it. I think that's a great reason to try it. So we have the community edition. It's free. If you're a smaller project, use the community edition. Yeah. So the question was, is Nickel a wrapper for some other sort of query language? No. Nickel is running on, there's a query service you spin up, and an index service you spin up as part of Couchbase. 4 checkboxes. They're checked by default. And that's what takes your query, processes it out, and then goes and makes queries to the index service, goes and makes queries to the data service. So it's its own thing. It's not a wrapper for anything else. Yeah, go ahead.
I would just like to add to that, IBM DB2 also supports SQL and decent block.
Yes, this is true, and also SQL Server 16, 2016, PostgreSQL, they also support JSON blobs and some types of SQL statements that you can read those JSON. Absolutely. I'm actually going to make a point about that if we have enough time later.
Yeah, I like to also say too is, I don't think the developer, I don't see them really use support, but I know like it's important to like admin and stuff like that. So you don't want to give this, there's so much logic actually that is built in the application itself as far as working with JSON, you may not want to give that access to like an admin. Instead they can just query it right on the database.
Okay. All right. All right. I want to talk about Couchbase, but I got to move on. I got 2 more to cover. Cosmos is the next one. This is the Azure-only Microsoft NoSQL database. I'm going to focus on just the document part of it. There's actually 4 different types of databases. There's document, key value, graph, and white column. Yeah, columnar database. Yeah, so with the document portion of it, there is a SQL language you can use to query these documents. However, it is not a full ANSI implementation. It is relatively limited. It's select only. There's no group by. There's no join. This is a relatively young database, so those things might help. I don't think they're going to add a join. This is a feature request. Go to user voice to see that. They've responded and said they're not really going to add that. It's not within their roadmap. The group by is one of the top requested features. We're going to add that eventually. If you like stocks, triggers, and user-defined functions, Cosmos supports all of these. You've got to write them in JavaScript. And speaking of transactions, here's the first time I've said this. This NoSQL database supports transactions in Visual Studio. Now Mongo has announced they're going to have some ACID supports in Mongo version 4. That's not out yet. And we're not really sure if it's going to be good or how it's going to work exactly, but they have announced that in the next version of Mongo. Of course, Microsoft has got .NET Core SDK available. Yeah, that's it for querying the document portion of it. Should also mention that Cosmos is API compatible with the Mongo API. So if you're using Mongo right now, you can switch over to Cosmos with relatively few changes in your actual code base. Section string, maybe a couple of, but it's the same API. So we kind of treating that Mongo API as a standard. Although it's interesting to see how quickly it will respond to the Mongo API changes, especially version 4, the new action. It also supports Cassandra API, Gremlin API, and maybe going to add a few more later, but those are not documents, so nothing's done yet. Scaling, this is all handled by Azure. It's all cloud-based. They do all the hard work for you in terms of scaling. Got some great stuff for geographic distribution, geographic affinity. You can select your consistency options. You can say, okay, I want this to be strongly consistent, or highly, or always available, or somewhere in between. This is in their website. They say guaranteed zero data loss during failovers. Now, I'm not sure exactly what that word guarantee means in this context. Do they mean it's never going to happen? Or do they mean they're going to refund the money when it does happen? I'm not really sure. I'm not even trying to make a joke here. I'm just not sure about that. Yeah.
Or they guarantee that all of your zero data will be
Sure.
Don't put zeros in our database.
Yeah, sure. Yeah, don't put in zeros. They're going to get lost. All right. So I mean, again, with the other ones, you kind of know how they work. You can handle, you can notify when things fail. But with Azure, you know, they basically control the entire data center, right? They can make some guarantees about the network. It's a good network. They test the network, things like that. But it is the ball is in their court. Usability, again, Azure is doing all that work for you. There's fewer decisions you have to make. .NET Core SDK are probably going to be pretty solidly supported with Microsoft. There's a local emulator you can run. So if you don't want to start building time against Azure, you can run the local emulator on your machine and develop against that. It's very cool. You have transactions, but they're limited to stocks. I guess I jumped the gun on that. So yeah, definitely some high marks of usability here with Azure. In terms of speed, basically there's a slider where you can say how much speed, how many transactions per second do I want to be able to handle. And of course, the more you want, the more it's cost, right? And this is again from the website. This might be outdated right now, but again, it's a guaranteed 10 millisecond latency reads, guaranteed 15 writes. And again, this word guaranteed, I'm not sure what that means. Does that mean it's always going to happen, or you're going to refund the money if it doesn't? I don't know. But it's Microsoft, right? So pretty fast, especially if you think about the number of data centers they have, that they'll do the distribution for you amongst all the systems. Very nice. Deployment, you are free limited here. It's going to be Azure and the local emulator on Windows. Here. There's also a Docker image with the local emulator. So hypothetically, you could deploy a cluster of emulators to a Docker, a cluster. Absolutely do not do that. Because the local emulator is locked to just specific credentials, and it's not meant for that, right? So don't do that. But anyway, there's a Docker image for that. It's probably a Windows thing. Okay. I'm not sure. But it's just there for convenience, I think. To the Docker run, and there it goes. So I'm sure some joker's going to try that, but don't be that joker. Support, just have one bullet point here, it's Microsoft. So all that goes with that is that it's not open source, which I feel like I didn't used to have to say that, but these days Microsoft is very much embracing open source. Cosmos DB is not yet part of that open source. I don't know if it ever will be. I don't know if it makes sense to open source it, but it's not open source. All right, any questions on Cosmos? Boom Azure portal. And I think it's actually like a Visual Studio Code plugin to help manage Cosmos. Maybe a regular Visual Studio plugin as well. That's all. Oh, there's a standalone studio application. Okay. Yep. All right. Last one is Raven. Anybody here ever use RavenDB? One guy, two guys. I know I'm doing it. All right. All right. So Raven. For querying your queries, you write them in Link. .NET. This is the database built on .NET. You can also query it from Java. They have something that's not quite linked in Java. It's called the Fluent API. It's kind of an imitation of Link, but it's not. For scaling, we're back to the problem of you have to configure sharding, you have to configure replication, you have to configure clustering. Until version 4 anyway. So let me just read you a quote here. This is a quote from Oren, the creator, the president of the company there. In Raven 3, each database is independent. You can set up replication and cooperation